Perfect. So let me get started. First of all, thank you for inviting me to present. Just a few points maybe about myself that I wanted to mention, and it's very much related to what I'm going to be presenting. So I'm wearing a couple of different hats. As you mentioned, Dassault Systems, that's the primary employer, but also I'm working in the Kaunas University of Technology. This is where I really combine a little bit of a research that I do with the university, with the private business in the Dassault system. Also teach students and share the experience. In addition to this, I'm also a member of the Object Management Group, which is non-profit standard organization. So in addition to private business and university research, I'm also involved in developing standards and best practices. Yeah, the fourth one is also related to really being involved in standards, specifically on the NATO side and the architecture framework for NATO. So let me give you a little bit of what we are doing. But before, of course, it's important that we speak the same language. So I wanted to give a couple of definitions here. First of all, the primary area of my work and my research is model-based systems engineering. It is model-based system engineering using models. So basically, first of all, when we speak about systems engineering, we speak about the approach of managing systems throughout their life cycle. And it's highlighted here, the engineered systems, because it's quite important for going further in my presentation, because there are different types of engineered systems. And we'll come to that in the next slide. But when we come to the model-based systems engineering, it's the saying that it's, doing systems engineering with models. But in general, it's probably slightly a little bit more than that, because when we involve models, then we involve tools, we need to manage them, we need to know how to use them. There is a learning curve for people, so that the process slightly changes. And it is described by INCOSE. INCOSE is the International Council of Systems Engineering. It's a non-profit organization that promotes systems engineering practices. And they describe model-based systems engineering as an approach to system engineering that focuses on creating, managing, and using digital models as the primary source of exchanging information between stakeholders. So basically, that would be the definition. Now, if I switch to the next slide, INCOSE also defines 3 types of engineered systems. Those are products, services, and enterprises. And it's quite important to distinguish between these 3 systems, because engineered systems, because these are really different approaches that we use to engineer products, to engineer services, and engineer enterprises. It's because when we speak about products, the products are relatively simple. Of course, products can get quite complex in size, but they're still would be simple compared to services and enterprises. When we engineer products, we deal with verifiable requirements. We really don't have too much human resource considered as a part of the system. So it's more, we work on the technical system, where we go towards services and enterprises. We move towards socio-technical or socio-economical space, where we have more uncertainty. And when it comes to the enterprise, we have fuzzy requirements. We cannot usually verify them. There's a lot of risk. There are a lot of uncertainty, because we have many human resource and their interactions involved in an enterprise size system. And service is somewhere in the middle between the product and enterprise. And services are composed of products, and other services and enterprises are composed of services and products, and can be also other enterprises. So just to make sure we speak the same language again, it's important to understand how we define enterprise. It is not it's not really organization where most of the people tend to think. We define enterprise as a large undertaking, especially one of the large scope, complication and risk, and usually it's distributed across geography and time. So it gives all those different perspectives, such as, you know, spatio-temporal, socio-technical, socio-economical, and compared to product, it gives way more complexity. And this is where it comes to the different approaches that we use for different type of system. So this is where really the major focus of my work and my team's work and my team's research is really focusing on, is defining those best practices and defining those methods to be used for a different system, for the different system engineering. Where we start from product, we have what we call Magic Grid. We used to call it MBSE Grid in the past, but this is one of the area of researches. I will jump to that a little bit further, where we focused for quite a long time already. Just keep improving it, keep getting feedback from the industry. And then when it goes towards enterprise, this is where the Unified Architecture Framework is the standard by the Object Management Group, which I currently chair in the Object Management Group organization, is where we use for complex services and enterprises. But then, of course, there are special uses. Like if we speak about US defense, then we speak about Department of Defense Architecture Framework. If we speak about NATO, we speak about NATO Architecture Framework. But those are very much related to the Unified Architecture Framework, which is kind of approach to engineer services and enterprises. Of course, tools are important, and I should mention that because the work I do with Dassault System is really related to tools to provide software to engineers. And this is where, you know, those standards come to play, because we provide tools to develop systems using these standards. And this is where in the system we have 3D experience platform, which is kind of a hub for all the different types of engineering. And it's kind of that brings all those different disciplines together. And then when it goes specifically into systems engineering part, we have cyber systems engineer and system of systems architect applications on top of the 3D experience platform to deal with the different types of systems engineering. And you know, it's really important to bind all those different aspects. It's not all about the tools, but it's also about methodology. And then when it comes to methodology, it's all about the best practices and the research that we need to do to make sure that we evolve, that we truly address the needs of our clients in the Dassault Systems. So let me jump now, after just giving a little bit of a background, let me jump to the research. Truly major areas of research, I would say there are probably four. Of course, you know, in every one of those areas, there are many different publications done. First of all, my PhD, which I did quite a long time already, it's 15 years ago, it was on the service-oriented business and information systems alignment method. So it was truly looking into the existing software applications in the organization and making sure that the software that organization owns really address the need on the process side, and the way how this could actually be aligned using systems engineering practices. Then on the other side, when I joined Dassault Systems, before Dassault Systems, we were a company called No Magic. Then we were acquired by Dassault System. But this is where we started another approach, because we were doing a lot of systems engineering consulting, and what was clear that every consultant in the company is using a different approach. So this was obvious that we need to unify, because when people start leaving job, we really lose knowledge because we don't know how to work with the client. We don't know the specific methodology they're using, and this is where, when I start leading the team, I actually come up with the idea that we need to have unified approach, and we come up with the MBSE grid, simplified approach for modeling complex systems. This is where we put multiple different publications together. We're still working, we're still continuing, we're still expanding. And it kind of became a common approach for the entire Dassault system of doing systems engineering, which is truly quite a big achievement already when you're acquired, and your approach that where you spend a lot of time is really taken in as the major approach for system engineering in the company of 25,000 people. Then another area is really working with students, supervising students. Recently, I supervised PhD student, and the topic we did was primarily model-based acquisition. The full name was Model-Based Evaluation of the System of Systems Architectures Used to Perform Trace Studies and Sensitivity Analysis. That very a little bit trace back to the PhD thesis. However, in this case, we focus not entirely on IT systems, not entirely on software, but we really focus on different types of systems. And the way, the process, and how it could be handled in the digital environment of really being able to select the right system for the right work, and make decision, make or buy for the specific case. Finally, also there is a lot research ongoing on the unified architecture framework, which I mentioned before, and we're truly trying to see how it can be applied for the multiple different problem solving. This then is a great feedback to go and enhance the standard, and then the standard moves to industry. Then it's kind of a loop. You go from research to standard to industry, and then feedback back to the research, and so on. So these are four major areas of research, and truly, being involved in the standard development organizations, it really helps to, as I mentioned before, it really helps to get that feedback and to push some ideas that we prove through the scientific researches into industry. So for example, on the object management group, we're working on the systems modeling language. We've been working on unified profile for Department of Defense Architecture Framework and Ministry of Defense Architecture Framework, UPDM. It was later replaced by Unified Architecture Framework. We work on the Unified Architecture Framework now for quite a long time. Keep improving it based on the researches and industry feedback. Executable UML, also risk analysis, assessment, modeling language, and there are way more, but I just highlighted the major ones that we truly invest quite a lot of time and resources. Now on the NATO side, there is specifically one standard, is NATO Architecture Framework, where we're truly involved. It's again systems engineering, it's again acquisition. So basically the same topics, it's just a specific area. And then in COSI, International Council of Systems Engineering, is where we actually work with the different system engineers on defining best practices of how to apply these standards. So it all kind of fits together, all puzzle fits together into the single piece. Then, of course, industry feedback. We're limited in time here. I will not jump into every one of these projects, but I just put some hyperlinks here. So if you're interested, you can download the presentation, and you can go on every one of these different use cases and watch the video on YouTube presented by their respective company employees, right? For example, applying QAF for dairy and livestock production systems engineering from John Deere, applying QAF and the Airbus MBSE framework within future combat air system development, and then going to look to Deloitte, going digital, and the way how these standards that I mentioned really serve towards digital transformation. Now, maybe a couple of facts, kind of a summary about the input to the scientific community that we do in the past 20 years. It's a little bit less than 20. It's I rounded up it a little bit. It would probably be around 16 years, 17, almost 17 years now. So we put 30 papers together, over 30 papers together. We wrote 3 books, the fourth in progress. We did many presentations and workshops and tutorials in the different conferences in IEEE, in Springer, in COSI, and other organizations, conferences arranged by other organizations. And recently, I also find out interesting research where bibliometric analysis has been done on model-based systems engineering research, and it was really also kind of enlightening to find my name in those most influential researchers in the area, which means that we truly do some significant input to the community by performing those researches. A few recent researches, I will not go into very deep details, so don't worry, I will not really take a lot of time here. But just to give you example of 2 of the recent researches we did. So one together with the partner company, SC Studio, we did research called System of Systems: Global Solutions to Global Problems using UAF. Our core goal of this research was really to see if the standard is really capable to handle a true system of system problem, which really goes way beyond a single enterprise. So this is where we have multiple enterprise connected together, and we really looked into the global copper market. We had quite a lot of data working with medical device manufacturers, and we've seen issues of not really copper supply, copper demand actually going really high up, and not too much recycling or processing in place. And we try to analyze a little bit, how can we use Unified Architecture Framework standard to be able to analyze strategically where truly the problem is, what are the capabilities of every one of those enterprise, and how one enterprise impacts the other, and what are the drivers, and how we can come up with the right drivers for the right enterprises so they really start changing. What do we really need to do to implement those capabilities of recycling, of reprocessing, and reusing copper, as opposed to really rely on the very limited supply. Another research that we recently did was focused towards an approach for co-executing system models at the enterprise level. So this is where we try to look into a little bit, again, model-based acquisition space, and this is where at the enterprise level we define what kind of systems we need. But then when it goes down to the different system make or buy decision, this is where if we in any case either we make them or buy them, we truly think that we need models for those systems, and then we need to connect those systems back to the enterprise model and be able to perform some analysis and make decision on which system do we truly need to buy, or do we make it. So this is more kind of automated decision-making approach by connecting enterprise level and the system level, and again, different practices are used to those, right? So we have to make sure and propose the right way to really connect these different worlds with the enterprise service product, etc. So that's all from my side. Basically, the main message of this presentation is that with the research, we help improve standards and we help industry to apply these standards and provide us feedback where again that encourage us to continue with the research and then again go and improve standards. And this is kind of never-ending loop, right? So I think this is kind of a duty of my team and me really to continue this loop, this wheel spinning, and actually improving the way we do systems engineering in the future. So thank you very much again for your time.